Chapter 22 is called What is a Test of Significance? But the way that we usually refer to tests of significance in statistics is by using the term hypothesis test. We're going to start right off with an example. A company claims that it has a 5% complaint rate for its products. A consumer protection group thinks the percent is higher. A survey of a random sample of 400 product owners shows that 33 had complaints. Find P hat. P hat is the number in the sample that had complaints divided by the number of people in your sample. The number that had complaints in our sample was 33, and there were 400 people in the survey. That works out to be 0.083, and we'll round it to 8%. Now, assume that the company's claim is true and that P, the proportion of all customers who complain, is really 5%. If the company's claim is true, what is the probability that we'd see a P hat in our sample of 8% or more? We can compute this probability because we know 3 facts about the sampling distribution of P hat. We know how P hat varies from sample to sample. Recall the 3 facts of the sampling distribution of P hat, as long as you have a large enough sample size, are that it's shaped like a normal distribution, it's centered at the true P, and it has a standard deviation of the square root of the true P times 1 minus true P over n. So, we've drawn the normal distribution for you, and we just need to find the mean and the standard deviation of that normal distribution. Well, the mean of the normal distribution is the true P, which we're given as 0.05. We're going to assume that the company is telling the truth until we find evidence otherwise. The standard deviation of this normal distribution is the square root of P times 1 minus P over n, which is the square root of 0.05 times 1 minus 0.05 divided by 400. And if you punch that in your calculator correctly, you're going to get 0.01 or 1%. So now we can label our normal distribution and see what the probability of observing a P hat of 8% or more is. So the first thing we label is our mean, and that's 0.05. And we know that our standard deviation is 0.01. So one standard deviation above average would be a P hat of 6% or 0.06. 2 standard deviations above average is 0.07, and 3 standard deviations above average is 0.08. 1 standard deviation below average is 0.04, 2 standard deviations below average is 0.03, and 3 standard deviations below average is 0.02. So now that we've got our normal distribution labeled according to the 3 facts that we know about the sampling distribution of P hat, we can find the probability of seeing a P hat of 8% or more. That is being to the right of 0.08 in this normal distribution. And we know from knowing the areas of our normal distribution, of our normal curve, that just 0.15% of area is out there, out of the 100%. So only 0.15% of the time will we see a P hat of 8% or more. We would only see a P hat of 8% or higher 0.15% of the time if the company were telling the truth. So what does this mean? This means that we saw a really rare result if the company was telling the truth. We couldn't expect to see a P hat of 8% or higher very often if the company's claim was true. So, since we saw a really rare P hat under the company's claim of being true, we're starting to think that maybe the company isn't telling the truth. What we have just done here is an example of a hypothesis test. A hypothesis test checks sample data against a claim or assumption about the population. The company's claim that the true complaint rate is 5% is called the Null Hypothesis. The Null Hypothesis has special notation. This capital H with a subscript of a capital O is called H naught. The null hypothesis in our hypothesis test was that the true percent of complaints is 5%. The word is, in math language, means equals. This is a good way to remember that the null hypothesis always gets the equals sign. So our null hypothesis is that P, the population proportion of complaints, is 0.05. The null hypothesis is what we have no choice but to believe until we find evidence otherwise. Now, the consumer advocacy group believes that the true complaint rate is higher than 5%. They're looking for evidence that it's higher than 5%. This claim is called the alternative hypothesis. The alternative hypothesis is the one that you're actually looking for evidence for. It's also called the research hypothesis. In our case, the consumer advocacy group thought that the true complaint rate was higher than 0.05. Notice the notation for the alternative hypothesis is a capital H with a subscript of a capital A. The A stands for alternative. Since the research hypothesis here was that they thought the complaint rate was higher than 5%, that's why we say that we think P is bigger than 0.05. That's what we're looking for evidence for. In general, the alternative hypothesis gets the bigger than, less than, or not equal to sign according to what we want to find evidence for. Once the consumer advocacy group checked a sample to find the probability of observing a p-hat that much bigger than 5% or more, and quantified it with a number, 0.15%, this is called the p-value. A p-value is similar to the probability in a criminal trial using DNA evidence. A small number is evidence against the null hypothesis or for the alternative hypothesis. Since we're using the p-value to summarize the amount of evidence we have against the null hypothesis, and we're assuming that the null hypothesis is true until we find evidence otherwise, the low p-value means that you saw a rare result if the null were true. So the smaller the p-value, the more evidence you have against the null hypothesis. Now, how do you know how low the p-value has to be in order to say, okay, we have enough evidence against the null hypothesis that we're going to say we don't think the null hypothesis is true, and we think our research hypothesis is true? When you need to make a decision based upon your p-value, you're going to want to use a level of significance alpha. The level of significance alpha determines how low your p-value has to be in order for you to make a decision that the null hypothesis isn't true and you think your alternative hypothesis is true. It's a pre-specified cutoff for how low the p-value must be. If the p-value is less than or equal to the alpha, then we have statistically significant evidence against the null hypothesis, and another way to write this is for the alternative hypothesis. The rule that you're going to want to make sure you remember are these two decisions down here. These are the only two decisions that you're going to be making in a hypothesis test. Once you compare your p to your alpha, if the p is less than or equal to the alpha, you're going to say that it was low enough to reject the null hypothesis. And another way to say that is that you find evidence for the alternative hypothesis. If your p is bigger than your alpha, that means it wasn't small enough. So if p is bigger than alpha, you're not going to reject the null, and you're not going to find for the alternative. Two notes that I'll make here. A good way for you to remember the p is less than or equal to alpha, reject the null hypothesis rule is to say this in your mind. If the P is low, the null must go. So if the P is low, the null must go. Now, you might have thought that the wording was really kind of funny here and awkward on the other decision. If your P is bigger than your alpha, you're going to say that you do not reject the null hypothesis and you do not find enough evidence for the alternative. Why don't we just say we think the null hypothesis is true? Well, we avoid that wording the same way that we avoid that wording in the legal system. Think about the two decisions that a jury makes for a defendant. Either they find the defendant guilty or they find the defendant not guilty. We never say in the not guilty case that we proved the defendant innocent. We just say we didn't find enough evidence for guilt. Same situation if our P is bigger than our alpha. We're not going to say that our null hypothesis is true. We're just going to say that we didn't have enough evidence to find for the alternative hypothesis. That was a brief introduction to hypothesis testing, and next we need to do some examples.